Good afternoon. My name is Hannah Stevens. Here with me is Victoria Lyons, Toyin Shoimimo, and Jacqueline Davis. The date is Monday, January 9th, 2017. The time is 5 p.m. and we are currently at Victoria's house. Today we will be talking about 1D kinematics. The foundation of physics is 1D kinematics. Without it, we would not be able to have free fall or projectile motion. Join us on our journey to learn more about 1D kinematics. Now I will be talking about scalar and vector quantities. Scalar quantities are quantities that have only magnitude and no direction. Examples are length, area, volume, time, and mass. Vector quantities are quantities that have magnitude and direction. Some examples are displacement, velocity, acceleration, and force. Vector diagrams are drawn using arrows. The length of an arrow represents the magnitude, while the direction of the arrow shows the direction of the vector. And in the example, we can see the vectors are VR and VC. The resultant is the square root of the sum of the squared vectors. The first vector is x, and the second vector is y. The resultant is the square root of x squared plus y squared. Now I will talk to you about distance and displacement. Motion is measured by the change of an object's distance from another object. Frame of reference is a point that a person assumes is fixed. Perception of motion depends on the observer's frame of reference. The train is moving from left to right, yet the boy is standing still. From your frame of reference, the boy is moving from left to right. Distance is the length of a path between two or more points. Displacement is the length of a straight line from the starting point to the ending point. Displacement is a distance with a direction associated with it. As you can see in the example, there is a curved pattern between point A and point B, yet the displacement is a straight line.
Hello, my name is Victoria Lyons, and I will be talking about speed, velocity, and acceleration. Speed and velocity are two very similar quantities that can easily be confused with each other. The difference is that speed is a scalar quantity, while velocity is a vector quantity. This indicates that while velocity is because speed measures distance per unit of time, while velocity measures displacement per unit of time. Meters per second is the most used unit to measure speed and velocity, but kilometers per hour is also very common. In the picture, you can see one car going west and another car going east. The speed is 25 meters per second for both, but for the one going west, the velocity is negative 25 meters per second, while for the one going east, the velocity is just positive 25 meters per second. Acceleration measures the rate of change of velocity. Since it deals with direction and can be positive or negative, it is a vector quantity. It is measured in meters per second squared. Acceleration is found by dividing the change in velocity by the change in time. If the velocity is constant, the acceleration is zero, as we will be discussing in the next slide. Uniform acceleration occurs when the velocity is constant. When graphed on a velocity time graph, the line is straight and either increasing or decreasing to indicate that the velocity and time have a constant rate. If there is an acceleration time graph, the line just goes straight across. In the diagram on the left, the slope indicates the acceleration. Since the line is inclining without any curves, the graph on the right, the acceleration time graph, is straight and flat.
Hi, my name is Toyin, and I will be going over graphing motion. Graphing motion. What is a graph composed of? A graph is composed of an x-axis, which is the horizontal, and a y-axis, which is vertical. On the graph, there is a line that has a slope. The slope is the ratio of the rise, the y-axis, to the run, the x-axis, of a line on a graph. A taller slope means a steeper line. Motion graphs continued. Motion graphs are an important tool used to show the relationship between position, speed, and time. It also shows how position, speed, and acceleration changes over time. These graphs are called position versus time, velocity versus time, and acceleration versus time, respectively. The slope of a position versus time graph is velocity, whereas the slope of a velocity versus time graph is acceleration. Finally, the slope of an acceleration versus time graph is undefined. Motion graphs continued, part 2. The first picture is a position versus time graph. The line is pointing downwards, which indicates a negative slope. This means the object is slowing down or decelerating. The second picture is a velocity versus time graph. The line is pointing upwards, which indicates a positive slope. This means that velocity becomes more positive with time and the object is speeding up. Free fall. A free-falling object is an object that is falling due to gravity. Gravity on Earth is always negative 9.81 meters per second squared. So this is a constant. It is negative because the force of gravity pulls down. The velocity at the highest point of an object's path is 0 meters per second. Common formulas that are used in free falling are change in velocity equals vertical displacement over time, gravity equals change in velocity over change in time, vertical displacement equals initial velocity times time plus 1/2 gravity time squared. And finally, final velocity squared equals initial velocity squared plus 2 times gravity times vertical displacement. Vector and vector resolutions. Vectors have magnitude and direction. Magnitude represents size. Vectors are represented by an arrow. They are also drawn from head to tail. Resultants are drawn from tail to head. They are represented by a dotted line. In the example, it shows a vector that is 50 meters at 30 degrees. This has been scaled down to where it can fit.
Hello, my name is Jacqueline Davis, and today I will be talking to you about projectile motion, as well as 3 scientists who have helped shape physics. Let's get started. Projectile motion is a form of motion in which an object is thrown near the Earth's surface and moves along a curved path while under gravity's hold only. It is a combination of vertical and horizontal motion. Vx and dx equal the horizontal velocity, while Vy and dy equal the vertical velocity. An example of projectile motion would be Tony throws a ball at 31.2 meters per second at 36 degrees above the horizontal. It strikes a wall that is 6 meters away. How high on the wall does it hit? First, you use cos or cosine multiplied by 36 degrees and as well as 31.2 meters per second. And that would give you 25.24 Vx, which is your horizontal velocity. Next, you would divide 6 meters by your horizontal velocity, which is 25.24, to give you your seconds, which is 0.24 seconds. Then you would multiply 0.5 by 9.81, which is Earth's gravity, and never changes, times the seconds, which is 0.24, to give you your meters on how high the ball hits, which is 1.1772 meters. Now we'll be talking to you about 3 scientists, Galileo, Aristotle, and Newton. Aristotle and Galileo realized that depending on the weight of the object that is falling, it may begin to fall faster or slower. Newton discovered the 3 Newton laws, which he is most famous for. The first being, An object at rest stays at rest unless acted upon by an unbalanced force. This is called the law of inertia. The second one is the acceleration is produced when a force acts on a mass. And the third law is for every action, there is an equal and opposite reaction. In conclusion, 1D kinematics is the foundation of physics. Scalar and vector quantities are integral to many concepts in physics. Understanding kinematics is the beginning to understanding complex concepts of all of physics. Thank you for listening to our presentation, and have a nice day.